Hey, Ralph. You okay?
Oh, I wish you wouldn't creep up on me like that.
What are you doing?
Well, to begin with, I need to find my 27mm wrench.
I don't suppose you mean this one.
Where did that come from?
Strange things happen. So, what are you doing?
Adjusting bearings.
Adjusting bearings? I have no idea what that means.
Well, it used to be a normal procedure.
And what exactly are you adjusting?
The play.
The play.
The bearing play. That is the play between the rolling element and the inner and outer bearing race. In the case of this car, it has to be controlled and readjusted every 10,000 miles.
Uh-huh.
You don't really know what I'm talking about, do you? Why do we need bearings at all?
What?
Look at it like this. Think practically. Rub your hands together, like this. Really hard. And what's happening?
It gets warm.
And what else?
It isn't easy.
Now put this extension bar between your hands and try it again. And?
Well, it's much easier, of course.
Exactly, because there's a rolling element in between. And that's the principle of rolling bearings. Maybe you've heard of the company called Kugelfischer. It is what FAG used to be called in the past, and now is part of the Schaeffler Group. Mm-hmm. And this Mr. Fischer, way back, developed a milling machine that made it possible to manufacture perfectly round balls for the very first time. That makes FAG the oldest ball bearing manufacturer in the world and the pioneer of the rolling bearing industry.
Wait a second. To begin with, you were talking about rolling bearings, and now you're talking about ball bearings. So there are two different types?
Two. Right now, FAG has over 200,000 different bearings available, starting with the smallest miniature bearings used in dental drills, all the way up to giant bearings used in mines, wind turbines, and the aerospace industry. But today we'll just talk about cars. You could say that rolling bearings is just a general term for all bearings in which you find rolling elements, which might be balls, tapered rollers, or pins, amongst others. The basic construction is always the same: inner race, outer race, rolling element, and the so-called cage, which holds the rolling elements in position.
And what have you got?
Me?
The wheel bearings in your car. Which rolling elements?
Well, and here you'll find classic tapered roller bearings.
So that's probably not the most modern method.
No, you can't really say that. Tapered roller bearings are still used today and can, in fact, be the best option depending on the demands. And there have also been technological developments leading to different generations.
Let me guess. You've already set them all up for me in the training room, right?
Of course, or there wouldn't be any point in this film, would there?
Right again.
So here we have the different generations of wheel bearings, and here on the monitor on the top left is a tapered roller bearing.
So, that is this one here, right?
Exactly. This kind of bearing is used on the front axle of my classic car, but also on the non-driven axles of modern cars.
Okay.
Picture this. There are always two bearings arranged in mirror position. They have to be lubricated, sealed, and then adjusted during installation. These two bearings are now integrated into one unit, and that is why the first generation is the development of the tapered roller bearing.
Yeah.
This bearing is pre-lubricated, sealed, and can be adjusted by tightening, which increases the torque. Another variation of the first generation unit is a bearing with balls.
Mm-hmm.
And you can see that this tiny contact surface means minimal resistance.
Let me guess. So this depends on the demands I make on the bearing. Here I'm carrying more weight, and here I have a lower rolling resistance, right?
Right.
Okay.
Additionally, starting from the first generation, it's possible to integrate a magnetic encoder into the sealing ring.
What's that?
The magnetic encoder provides a rotational speed signal, or wheel rotation reading, for ABS, ESP, or ASR system, among others. And with the second generation bearings, installation becomes even easier.
Mm-hmm.
The bearing already contains a flange to connect it to the brake disc and the wheel, or the bearing is connected directly to the stub axle. Here's something special. The 2.1 generation bearing has a retainer that holds the bearing in an axle position in the knuckle.
Mm-hmm.
This replaces the circlip that's used in conventional bearings.
Mm-hmm.
In addition, bearing play is adjusted during production by means of a process called orbital forming.
That means less work for the mechanic.
Yes, sure. It's quicker, so the job's done faster.
But here we have a flange on each side, right?
Yes, but that's the third generation bearing.
I see.
One flange is fixed to the knuckle and the other is attached to the brake disc and the wheel.
So I can save even more time during fitment.
That's correct.
And what's the cable for?
That's the connector for the integrated ABS sensor that provides the rotational speed signal for ABS, ESP, ESR, and so on.
Okay, good.
Here's another special design featuring a patented face spline.
How does it work?
I actually set up a model.
Oh, Ralph, you'd lose your head if it weren't screwed on. Is this what you're looking for?
Thanks, you're too good to me. The face spline transfers the power via the drive shaft to the wheel bearing, enabling a 50% increase in torque in the same sized design.
Wow, that's a lot.
Here we're looking at an LFT seal,
Which stands for?
low friction torque.
Says it all.
It does just that.
So it rotates easier.
It rotates a lot easier. It's shown in that working model over there. Try it yourself by spinning both wheels at the same time with your hands.
Oh, yeah.
You see, the LFT seal runs for much longer, less resistance, and more efficient.
Okay, I understand that. But let's go back to the wheel bearings. So we can't really say that the first two generations are completely outdated.
Not at all. For each new car model, we develop a wheel bearing that is the best solution for the demands of the manufacturer. It doesn't matter if it's a third, second, or first generation. What matters is that the wheel bearings in general are a safety critical component. They're responsible for making the vehicle drive safely on the road. And bearings have to be able to handle huge forces, the weight of the vehicle, during acceleration, during braking, and when going around corners.
Yeah.
Look here. Take this model, like this.
Okay.
Imagine there is a wheel here. Can you see what happens when you hit the curb? It's subjected to huge forces.
Oh, yeah. I get it. I presume that you want to demonstrate that a wheel bearing like this also has to be replaced at some stage.
Exactly. And hitting the curb is one of the most common reasons why bearings have to be replaced.
And how do I know when the bearing is defective?
Wheel bearing defects don't happen solely because of hitting the curb. There are other factors involved. Bad roads, potholes, etc. And it will probably take a few miles until you notice the noise. But be careful. It doesn't necessarily have to be the wheel bearings. It could be any other component, like tires or parts of the chassis. Are you wondering what the card's for?
Yes, a little.
Then let's go and see Tommy in the garage. He's replacing a worn wheel bearing right now. And then you can see what the card's for.
Okay.
So here we can see how Tommy is replacing a first-generation wheel bearing. The procedure can, of course, vary depending on the vehicle model. In order to get to the bearing, he needs to remove the wheel, the braking system, and the drive shaft.
Is that the wheel bearing already?
No, that's the wheel hub, and with first-generation wheel bearings, the hub is not part of the bearing, so the hub has to be removed from the center of the bearing. With the help of a special tool, Tommy is able to replace the bearing whilst the knuckle is still on the vehicle.
That means he could do it another way.
Well, without the special tool, you would have to remove the complete steering knuckle and use a hydraulic press to press the bearing out and back in again. Eventually, you may have to carry out a complete wheel alignment.
So that, of course, means more work and higher costs for the customer.
Exactly, and it takes longer.
And what's happening now?
He's using the hydraulic cylinder to press the hub out of the bearing. In most cases, the inner race of the bearing will be stuck to the drive flange.
So it gets pulled out too.
Right.
So the wheel bearing is totally destroyed and it's impossible to use it again.
Correct. And the inner race has to be removed from the hub in a separate procedure.
How do they do that?
Tommy will show us on the workbench. Here Tommy is using a special tool for removal. It's quick and simple. The removal tool grabs the inner race. When he turns the spindle, the inner race will be removed from the hub. If the hub is in good condition, it can be used again. So, now back to the vehicle. You can see here that Tommy is removing the snap ring. The rest of the wheel bearing is still attached to the steering knuckle, and that has to be removed too.
Wow, he really does have an impressive range of tools. Does he really need all of them?
Depending on the vehicle model or the diameter of the wheel bearing, he needs different tools to carry out the repair. Now he will use the hydraulic cylinder again, but this time it is fitted with a different tool.
And now he has to pump again. Poor Tommy.
But take note, before fitting the new wheel bearing, the bearing seat has to be cleaned and checked thoroughly.
Okay, I understand. So, new wheel bearing?
Hey, you have to be careful with that.
What? But why?
Here we have a wheel bearing with an integrated magnetic encoder. It captures the rotational speed of the wheel for ABS, ESP and alike. If you were to lay the encoder side close to a magnet, like for instance this magnetic rod, you could damage the encoder and the rotational speed wouldn't be captured accurately.
So that means the wheel bearing is broken even though it's brand new.
Exactly, so it's best to leave it in the packaging for as long as possible and take it only out when it's really needed.
Okay, but there are several other components in the box.
We always provide additional components if they're necessary for the repair, all OE quality components of course. Here we have the nut for the drive shaft and the circlip for the bearing, fittings for the track rod end, or the braking system could also be included if needed.
And what are the notes about?
That's the fitting instructions, and they are very important. In fact, this one describes exactly what I told you about the magnetic encoder. It's important to know which side the encoder is so that the bearings can be fitted the correct way round. And this is where you can use the card.
Oh yeah, you mean this card? Yeah. How do I use it? What can I see?
The card will show you which side of the bearing includes the magnetic encoder.
Okay,
So now that Tommy knows, he's prepared the tools and is ready to go.
let's go.
It's important that the tool is placed carefully and not tilted. Otherwise, the wheel bearing seat could be damaged during assembly. When the wheel bearing is in position and the tool has been removed, the snap ring can be fitted, but make sure the opening is pointing down,
Why is that?
because that position prevents moisture accumulation between the wheel bearing and the snap ring.
Great tip, that.
So now the wheel hub will be pressed in and then everything else can be put back in place. Drive shaft, braking system and wheel are fitted. Of course, everything needs to be fitted using the correct tightening torque recommended by the vehicle manufacturer.
And you can find these torque settings on RepExpert, our online garage portal, can't you?
Exactly. So let's quickly switch vehicles. Thanks, Tom. Great job.
Amazing.
So here we have a vehicle with a 2.1 generation wheel bearing that has been fitted with a snap ring. The process to replace it is a little less complicated, but we still have to remove the wheel, braking system and drive shaft.
But if I didn't have a special tool available, I'd still be able to carry out the repair using a hydraulic press, right?
Yeah, it's possible, but after the repair has been completed, you might have to align the axles.
So it'd always be faster to do it with the special tools, yeah?
Definitely. As far as this wheel bearing generation is concerned, the hub is removed with the bearing attached, and again, we recommend using the hydraulic tool.
Wow, that was fixed tight, huh?
Yeah, but it has to be. Here you can clearly see the groove where the retainer clicked into place. And the snap ring is completely destroyed.
Okay, so that means that this wheel bearing should not be used under any circumstances.
Never. And it's also important to point out, clean, remove rust and check the bearing seat.
Great, and it's also important to remember that the new wheel bearing should only be taken out of the box when you're ready to fit it, or it could get damaged, right?
Very good. Well remembered. And again, we are using our special tools. Though the difference here is that there are two clamps and the appropriate bolts to hold the inner and outer races together. Because firstly, the bearing has to be pressed in over the outer race, and secondly, the snap ring has to be held in place. Otherwise, it would not click into place correctly.
So, I cannot simply take the tool and press the wheel bearing in?
No, that way you could fit it over the wrong bearing race and the snap ring wouldn't be in the correct position.
I don't understand.
Okay. The force would be directed from the hub into the inner race, through the balls, and onto the outer race. And that would ultimately lead to premature failure of the bearing.
So that means I always have to use these clamps.
Absolutely. So, Tommy is almost pressed in the bearing. In a moment, we'll hear how the snap ring clicks into place. Now, it's important to continue to increase the pressure to ensure that the snap ring has been fully clicked into place. By the way, the part that we offer is identical to the one that is fitted by the vehicle manufacturer. And, especially with this wheel bearing, there are other suppliers that do not use the snap ring. But do you really think a vehicle manufacturer would fit a wheel bearing with a snap ring if it wasn't absolutely necessary?
Nope.
You see? Now everything has to be reassembled. And again, you can see there are additional parts in the box that are necessary for the repair job. And again, they are all OE quality parts. So you can see it's not rocket science. Yet there are rules that need to be followed or something could go very wrong. As far as the third generation wheel bearings are concerned, the whole procedure is much easier. We don't have to press it in anymore, it's simply bolted on.
Oh yeah, that's much easier. I understand. Well, Ralph, that was fascinating. I had no idea that there was so much know-how hidden within a wheel bearing.
That's the reason why we offer training courses dealing with wheel bearings, because people often think that there's nothing to it.
Yes.
But now you've seen what happens behind the scenes.
Yeah, absolutely.
So, everything's clear?
I think so.
Good. Then I can go back to taking care of my classic car.
And now, ladies and gentlemen, you can see Mr. Ralph Kumai in the episode Adjusting Wheel Bearings with Your Bare Hands because the wrench is missing.
Eh? I don't believe it.
You don't? I do.